subtracting of radicals. So let's remember from our first day with this that to be able to add or subtract radicals, the radicands, which are the numbers underneath that square root symbol, have to be the same. They have to be like terms. So this first little slide, we want you to fill in the words that go along with the steps to this process. So first of all, simplify any radical that can be simplified. And we've been talking about that the last few days as well. Then add or subtract the coefficients of the terms that do have the same number and the radicand. And then that would be the process of adding and subtracting radicals. So if we look at our first example here, we notice that the radicands, the numbers inside the radicals, are already the same number. So all we have to do is subtract the coefficient. 5 minus 3 times the square root of 11. And 5 minus 3 is just 2. So we have 2 times the square root of 11. And that is the answer to this particular problem. Okay, this next one. We notice we got 20 and 45. We can't add those together yet because those radicals are not the same. But we can simplify. So let's break this down into 4 times 5. And 4 breaks down into 2 times 2 times 5. And now let's break down 45. We're going to break that down into 5 times 9. Or 5 times 3 times 3. So let's start circling our matching factors. We got matching 2's over here, matching 3's over here. So this first one can be written differently by taking out the 2 out of the radical and leaving behind that 5 inside the radical. Then we have 5 on this one that comes down, but we're going to bring out a 3 to go with it. And then our radical is going to have a 5 left inside of it. That's our radicand. So this second one, where we have 5 times 3, can be simplified to be 15 times 3. So 15 times 3 is, or 5 times 3 is 15, excuse me. Square root of 5. So then 2 plus 15 is 17 square root of 5. So there is our answer to that particular one. So we simplify the radicals, then add or subtract them if they are like terms. All right, let's check these two out. First of all, I'm going to put a -1 on that first one because we have a negative sign there. We want to make sure everybody knows that's a -1. Then we're going to simplify 12, turn that into 2 times 6, which simplifies to be 2 times 2 times 3. And we will circle the common factors. So one of those will come out and we'll have -1 times 2 times 3 left inside the radical. And -1 times 2 is -2 square roots of 3. Okay, well, so far so good. Let's do the other side now. We got 27, which I happen to know breaks down into 3 times 9. Or further, 3 times 3 times 3. Circle a pair of matching 3's, and one of them will come out and be multiplied by that 5. So that will give us plus 15 square root of 3. So -2 plus 15, when I combine those together, will give me 13 square roots of 3. All right, so let's see what our next example is then. Okay, -5 or -1. See, that's one that looks real familiar. Okay. All right, so -1 square root of 50, which is going to be the same as -1 times the square root of, I'm going to do this a little differently, the square root of 2 times 25, right? Which in turn would be -1 times the square root of 2 times 5 times 5. And then our next one, we're going to have -2 times the square root of 2 times 9, which will be -2 times the square root of 2 times 3 times 3. All right, so let's look at the matching pair we have there. We've got 2 3s, so one of them will come out and get multiplied by that 2 right there. So this will be -6 square root of 2, or minus square root of 2. One of these 5s will come out, get multiplied by that one. So we'll have -5 square root of 2. And -5 and -6 is -11 square roots of 2. Very nice. All right, I think we got one or two more here. 48, that one breaks down into 3 times 16. I like that one. Which in turn breaks down into 3 times 4 times 4. All right, so I notice I've got a couple of 4s. One of those will come out front, which will leave me 4 out there and a 3 left inside. Now I want to kind of point out that once we know what's going to be inside of our first radical, why don't we see if that number will go into our second radical, because if it will, we are off to a good start. So we're going to divide by that 3, and sure enough we get 4. So 3 keeps coming down, and that 4 factors down to be 2 times 2. So that means we're going to take one of these out front, multiply it by that 5, and end up with plus 10, plus 10, and then our leftover is that 3, square root of 3. Oh, look at that. 4 plus 10, square root of 3 would be 14 times the square root of 3. And that would be our simplified and added radical. Okay, this is the last example on this particular set. So 18 breaks down into 2 times 9. We better get a different color for a minute. And 2 breaks down into, well, this one breaks down into 2 times 3 times 3. And we have a 3 right here. So this 3, one of these 3's is going to come out of the radical, and we'll end up with this 3 coming down, and we'll have 3 times 3 square root of that 2 that's left over. And 3 times 3 is 9, right? Square root of 2. All right, so we're off to a good start. So now we see that there's a 2 left in this radical, so let's try dividing this other radical by 2 to see if it'll go in there, and that might point us in the right direction. Sure enough, 2 does go into 50 25 times, and 25 breaks down into 5 times 5. And then we're going to take one of those 5's out in front of our new radical, so that 5 comes out front, and we have 2 left inside. So we're going to finish this off by saying, well, what is 9 square roots of 2 plus 5 square roots of 2? 9 plus 5 is 14. And then 14 square roots of 2 is our final answer. Have a great evening. Talk to you later. So our Alex assignment is going to be number 76, adding and subtracting radicals, day 2. And remember to show your work.